Okay, hey guys, if you are watching this video, it's because you're working on the, hang on. You're working on the double muscle pedigree worksheet, or double the muscle using pedigrees, and you are struggling with it and you want some extra explanation for each of the questions. So in this video, that's all I'm going to do. I'm just going to go through each one of the questions on this worksheet and give you some extra help to answer the question. So how you could use this video, I would suggest make an attempt at every question. Watch the video so see my explanation of that question, and then pause the video, try the next question, again, play the video, get help where you need help. But don't just watch this video and write the answers in, because then you're not actually doing any learning with it. So let me pull this up on my screen. Okay, we'll do this one together. Double muscle pedigrees. Okay. If you've already watched the other video that I made, that means you've already done this much along with me, because this is what I did in the last video. I filled in the extra cows on the table. I shaded the people that have, the cows that have the recessive trait of double muscling. And now we're just going to work through these questions below. So first question, what do you know about Penelope's genotype? So let's go back and look at Penelope. Penelope was this cow right here. We just wrote in her on the pedigree. Penelope is shaded, which tells us she has the double muscle trait. And look, I just made a key for myself so I can use my key. If Penelope is shaded, that means we know her genotype is m, homozygous recessive, because she's showing the recessive trait. So I'm actually just going to write that on my pedigree right here. I'm going to write m, because that might be helpful later. And then I'm going to go back to that question and I'm going to say m, 100% sure. What do you know about Kirk's genotype? Okay, I want you to pause the video, try to answer this question, and then play the video and you'll see my answer. If we look at Kirk is not shaded. So that means he's going to have the normal muscle trait that's dominant. And there are two ways you could show the dominant trait. So we have to figure out, is Kirk this one or is he this one? So the trick will lie in looking at Kirk's offspring. Does Kirk have any offspring that show the recessive trait? Yes, he has Penelope. So that means Penelope got one of her recessive alleles from her dad. So Kirk has to have at least one recessive allele. So he has capital M, lowercase m. Sorry, let me make that a little bit more distinct. Capital M, lowercase m. He is heterozygous. We know that for a fact. So I'm going to go back to number 2 and write heterozygous. Pause this, try number 3, play it if you want the answer. All right, let's look at Jesse's genotype. Jesse, where is she? Okay, so Jesse is kind of in the same boat as Kirk. We know that Penelope got a lowercase allele from both of her parents. So Jesse, just like Kirk had to be heterozygous, Jesse also has to be heterozygous in order for Penelope to have gotten the recessive allele from both of her parents. You know what I mean? Okay, so that's what we know about Jesse's genotype. For number 3, it should be heterozygous. All right, number 4 and 5. What do you know about Faith's genotype? What do you know about Eric's genotype? This is a tough one. So I want you to pause the video, try to answer this one. If you're not sure what to do, play the video. I'll tell you the answer. So Faith and Eric, if we go up and look at Faith and Eric, okay, Faith and Eric are right here. We know that they have at least one dominant allele because, again, they're unshaded, which means they're showing the dominant trait, and that has to have at least one dominant allele. So I'm going to go ahead and fill in that first one for us, capital M, capital M. Okay, so the question really is, what's their second allele? Is it capital M? Is it lowercase m? Is there a way for us to even know? So if we look at their parents, there's no recessive traits in the parents, like those are both showing the dominant trait. If we look at their offspring, Jesse and Kirk, well, we just figured out that Jesse and Kirk are both heterozygous, but there's not like it's not like a Penelope situation where I know for a fact that there's two lowercase alleles. So Eric and Faith, all we know is that at least one of them has to have a lowercase allele so that Jessie could get her lowercase allele. We don't know who Jessie got that lowercase allele from. That's the thing. She could have gotten it from Eric or from Faith. We don't know. All we know is that either Eric or Faith has to have a lowercase allele. It could be both of them. Let me tell you a possibility. We could have Eric as heterozygous, Faith as heterozygous. That could totally be a possibility. That works. We could also have Eric as heterozygous, but Faith as homozygous dominant. That could totally work. Or we could flip it. We could have Eric as homozygous dominant, Faith as heterozygous. Any of those combinations would work with what our pedigree says. So we don't really know. What I would put for Eric and Faith, I'm going to leave little question marks there. On the actual writing part of this question, for Eric and Faith together, I'm kind of going to combine these. Okay, we know that, what was I going to say? Hang on, let me look at my wording really quick to make sure that this is going to make sense overall. Okay, aha. We know that either Faith or Eric must have a recessive allele, a little case m. And again, the reason we know that, remember, it's because they had a daughter who got a recessive allele from one of them. So either Faith or Eric must have a recessive allele because their daughter has one. So I'm going to combine these questions because it's really Faith and Eric. They're interchangeable here. They're working, like we're answering both questions at the same time. So at least one of them is heterozygous, big M, little m. We can't know. Like they could both be. They could both be heterozygous. We can't know for sure. Okay. I think that's the toughest one, so don't be overwhelmed. That's why we worked through it together. Let's take a stab at some of the next questions. So pause the video, take a stab at number 6. What do you know about Nero's genotype? Then play it, come back, get the answer. All right, if I look at Nero, which is a really great name for a cow. If I look at Nero, I know that Nero has the dominant trait because he's not shaded. So I know that he has to have at least one capital M. Question is, what's the second allele? Okay, I look at his parents, Jesse and Kirk. They could have given him either. Honestly, it was a 50-50 shot for them to give him the dominant allele or the recessive allele. So for Nero, I don't know. He could be this or he could be this. And that's as far as I can get. He's going to be one of those possible question marks. So let's go back and fill that in on number 6. We know Nero could be homozygous dominant or heterozygous. Can't know for sure, and that's okay. All right, pause it. Take a stab at number 7. Play this if you want the answer. Okay, if Gail's going to be a carrier, remember that's just another way to say that she's heterozygous. So we're asking, could Gail be big M, little m? Could she be heterozygous? Draw a Punnett square to justify your answer. Well, let's go up and look at the pedigree. Let's find Gail. Okay, Gail is right here. So I'm asking, is it possible for Gail to be heterozygous? Let's look at Gail's parents. Okay, so Gail's dad is Cody. Do we know for sure what Cody's genotype is? No. Cody could be capital M, or heterozygous. Dora, we do know what Dora's genotype is. We know for a fact that Dora has to be heterozygous because of this guy right here. Remember, if it's shaded, it's 2 lowercase m's, which means they got one from mom, one from dad. Therefore, Dora had to have a little allele to give him. So Dora is going to be heterozygous. So the question is, could Dora and Cody have had a kid that got that recessive allele from Dora? Short answer is yes, that's possible. Let's prove it on a Punnett square. Okay. So again, remember, I don't know if Cody's alleles are these or these. I'm just going to start by testing this one, the homozygous dominant option. I'm going to make a Punnett square to show that crossing with Dora's genotype, and we'll see if there's a possibility of Gale being heterozygous. So let's go back down there and do that. Make my Punnett square. I'm going to put Dora's genotype up here. I'm going to put one of Cody's possible genotypes over here, and let's cross them. If Dora and Cody had an offspring like Gale, what are the odds that Gale could be a carrier? I'll do the full table just for kicks and giggles. Looks like we have 2 out of 4 homozygous dominant, 2 out of 4 heterozygous, which means these are both going to be 4 out of 4 normal. They're both going to show the dominant trait, but is that a carrier? Yeah. So honestly, there's a 50% chance that Gale's a carrier because Gale was an offspring of those 2 cows, and all of their offspring have a 50% shot of being a carrier. So yes, Gale has a 50% chance of being a carrier. Cool. Next one. Could Missy be a carrier of the double muscle gene? Draw a Punnett square to justify your answer. Pause this, try it, come back, get the answer. Okay, let's look at Missy. Okay. Missy, what do I know about her? She's showing the dominant trait, so I know she has to have at least one dominant allele. Just like Gale, we're trying to ask, could that second allele be a little m? Could she be a carrier? We got to look at her sibling actually to tell us this information. So Missy's sibling Lance is shaded, which means he's showing the recessive trait, right? He's going to look like that. Lance is going to have a little m genotype, which means he got one of those from his mom, one of those from his dad. Bada bing, bada boom. Henry and Izzy have to be heterozygous because they had to give one recessive allele each to Lance. Okay, so if I know Henry and Izzy's genotypes, and I'm trying to figure out what could Missy be, I'm going to do a Punnett square with those 2 genotypes. So let's go back to the problem. Punnett square. We'll put Henry's genotype up here. We'll put Izzy's genotype over here, crossing them together. This is your classic heterozygous cross. We'll do my GNP table. Looks like I'm going to have 1/4 homozygous dominant, 2/4 heterozygous, 1/4 homozygous recessive. Okay, that means that I'm going to have 3/4 that end up normal, because normal is the dominant trait, and 1/4 that ends up double muscle. The question we're asking is, could Missy be a carrier? Remember, carrier means heterozygous. Is there a chance that she's going to be a carrier? Yeah. Again, there's a 50-50 chance, 50% chance. Yes. Missy has a 50% chance. Just like Gale. Okay. All right, number 9. Which cattle in Walter's herd could be crossed to guarantee a double-muscled offspring? I want you to think about what it would mean to be guaranteed a double-muscled offspring. That means your Punnett square would have to look like this. If every single offspring was double-muscled, look, we know that double muscle means that recessive trait. So every square would have to look like this. That would be a 100% guarantee of double muscle. So the only way I could get 100% guarantee of double muscle is if I had two double muscled parents. That's the guarantee to get all offspring double muscle. So the question is, do I have two cows in the herd that are double muscle confirmed? Let's go back and look. I do. Okay, currently in the herd, I have Penelope. She's the female. Do I have a male that I can mate with? Yes, I have Lance. He's a male. Ignore this guy. This was, oh gosh, was his name Alex? No, Alex is over here. Hang on. Oh, never mind. He didn't have a name. That was just Dora's random son that she had somewhere else. So he's not in the herd, so he wouldn't count technically. So my answer for number 9 would be Penelope and Lance. Those are the only cows I think that would give me that option. Penelope and Lance. Okay, this last question. Here we go. If Walter wants to avoid double-muscled offspring, which cattle should he cross and why? Pause it, take a stab at this, come back, get the answer. Okay, if Walter's trying to avoid double-muscled offspring, that means ideally he wants cattle with homozygous dominant genotype because they're not a carrier. There's no chance they're going to have a child with that trait. So let's look and see how many cattle we have that are homozygous dominant. Currently on the screen, there's only one that we know of for sure, and that's Alex in the top left, because we actually know Alex's genetics because he was the artificial insemination. Like, they have paperwork on his genes. So Alex is homozygous dominant. So we know for a fact that he should probably be the bull if we're trying to create a family tree that has no double muscling. The options for the cow, like the female on this cross, honestly, we have several different options. Personally, I would say Bella and Faith are probably our best bet for the other cow in that cross because we don't have confirmed information that they are heterozygous. The other cows, for example, like if you look at Jessie, we already know she's heterozygous, okay? If you look at Dora, we already know she's heterozygous. Gail, actually Gail, we don't know if she's heterozygous or not. We know there's a chance she could be. So Gail could be another option. Izzy, we know she's heterozygous, so she's probably not a great option. Missy would be a good option because she's still a possibility. I don't know. We don't know for sure. So basically what I'm saying is if we're trying to have maximum chances that we don't have a double-muscled offspring, we should pick either Bella or Faith or Gail or Missy. I think each of those would have equal chances here. I don't think that you can really deduce beyond that which ones would give you double muscle or non-double muscled offspring. So we'll say this. Alex is the only one we are 100% sure of not being a carrier. So in other words, having homozygous dominant. Okay, Walter's best bet is to breed Alex with either, what did I say? I think I said Faith, Bella, Gail, or Missy. Because we don't have confirmation. Like, we don't know for sure. Sorry, I'm going to say that. We don't yet know for sure that they're heterozygous. So there's a chance they could be homozygous dominant. And that's what we're looking for, right? We want another cow that's homozygous dominant. So what Walter would really have to do is he would have to systematically breed Alex with Faith, Bella, Gail, Missy, and then watch their offspring. And then after several generations, if he doesn't see a double muscle cow pop up, he could probably know then at that point that that cow was homozygous dominant. Okay. When you finish this, I do want you to turn it in. And now you know more about cattle genetics, so that's great. All right, just end the video because I need to stop recording.